Hello and welcome back to module number two. In this module, I'm going to talk about three different aspects of visual analytics. The first, I'm going to talk about the term itself. What is visual analytics? Then I will talk about what is the terminology that we are using in visual analytics. And then in the end, we are going to experience the first time creating we will collect data from Google search and convert it into a map and be able to illustrate what is the data actually means where the background is a map. So I'll try to make more sense of it throughout the lecture. I hope you enjoy it, and again, ask question if you have. So let's start with what is the definition. It's called early definition of the term visual analytics, defined the field as a science of analytical reasoning to facilitate interactive human-machine interface, which is a big terms, but in a sense, what is it really trying to achieve and how do we achieve that? The idea here is that we are trying to take large data sets, as I described in module number one, and trying to combine analytic techniques in order for us to convert it into visual analytics. But when we are talking about visual analytics, we have our own vocabulary or terminology. We have points, we have lines, we have a coordinate system, we have numbers, symbols, words, shading, and of course colors. One of the great visual historian is Edward Tufte. He wrote The Visual Display of Quantitative Information. This is quite the best-selling book on visualization or visual analytics, and he talks about the historical perspective on those terminology. So let's start with the basic points. Even there is only one point, one mark on a blank page, it still represents something. It still tells us a story that we need to unfold. A line is also part of our vocabulary that we are trying to display or to apply or convert verbal sentence into a line to make it more meaningful and be able to communicate through the line what we have found. So we have line composition, and each one of them is part of what we are trying to achieve in order for us to do that. Circle is another way. And we will learn about different circles and what they present and the color that capture them in order for us to tell more story. And of course, there's the text that we all know to apply to. And then there is the design patterns in the background. This is something that we will learn, and there will be a software application that we will learn how to apply or develop throughout. And of course, the biggest issue is the colors and what it represents. Example, even though I was born in the United States, I was brought up in the Middle East, which means that I have different set of colors that I like to see or make communicate differently than you are if you are coming from United States, or are you coming from the north, from Boston or New York, that green represents something, or coming from California where yellow is a strong color. Again, cultures and understanding of colors is a big issue in the visual analytic community. But again, I want to become more specific, and I'll try to do that by showing you example. If we will take a review of common chart formats, and such as bar chart, line chart, pie chart, and cluster plots, you will see that usually it doesn't allow us to apply many variables. And I will talk about variables very soon, but the idea is usually it consists of one variable. Example, visit. How many times the students visit my office on a daily basis, twice a week, weekly or monthly. And so it's only about one variable. It is the amount of visit to my office. Line graph is a little bit more extensive, which means that it will allow us to present two variables, day and the degree in Fahrenheit, or the temperature. And the idea is that as we go along towards the hurricane, the temperature rises. Again, the issue of two dimensions and how the visualization capture that. But in that idea comes the idea of coordinate grid, which means is the canvas, or the canvas is a good word for that we generate our visualization. We have the X and the Y axis, and we have a starting point, which is the intersection between Y and X. And this is important because if we want to convert the analysis that we did in statistics or analytics, we need to have some map or coordination system that we will be able to match. Simple Pi sometimes display quite well, and most people like it and try to employ that. But the problem with the pi is that if we have more than, let's say, 5 or 7 or 8 variables, it's hard to read and it's hard to understand. And in this case, again, this is the budget of the state, and we have different criteria. Example, police payment, fire payment, park and recreation, public works, street construction, and so on and so on. So all those things, when we were trying to capture that in one pie, it's usually overwhelming and we are losing track at what we're trying to achieve. Another way to apply, again, relationship between two variable is scatter plot, and it is quite nice, but again we will learn how to give additional element or a graphic terminology in order for us to communicate, instead of just throwing the lines and doesn't give us any indication where is the average or the data tendency goes. Does it goes up or does it goes down? Those are the questions that we always need to do. So why is your professor so keen not to teach you Microsoft Excel? Okay, and then this is a good question, and the issue for me is that Microsoft Excel does not give us the ability to create bubble chart, ring chart, distribution map, and heat map, and many more. Those limitation creates for me the ability that is limited. Excel is limited to the ability of what we can do, and this limitation stop the ability to portray the data as I see it fit into the visualization. What is so beautiful about Bubble Sheet is that the idea that we can have the size, the color, the texture of the bubble change from one country to another. And again, in this case, this is different countries, and this is beautiful because it's also aesthetic pleasing to the eye. Ring chart is also a very popular platform to visual analytics, and it started back in the Renaissance day, and it is the advantage that allowed us to compare similar data set. So again, the bar or the line bar, it's all standard, but we can create or involve in another dimension in order for us to display other variables or other components in order for us to also give a more pleasant or more transparent transformation of the data that we do. So one of the things that we are very keen in the visual analytic community is to talk about statistics. And some of you are taking my statistical class. To those, I will try to capture that in 4 or 5 slides just to make sure that we are in the same page. So the idea of statistics is the idea of collecting, describing, and provide interpretation to the data. The interpretation usually comes in words that you, numbers that you need to convert into paragraph or text in order to describe what you have found. There's 2 areas of statistics: descriptive statistics, which is the idea of collecting, presenting, and description of the data, and inferential is taking a sample out of the population and draw conclusion about the entire population. Example, we are heading towards election next year, and so we're going to hear about inferential statistics and what the sample draw about the popularity of one candidate versus the other. Example, I'll give you a simple example about descriptive statistics. So the idea here is that in descriptive, we often try to measure the entire universe and try to come up with a way for us to capture this idea, what it is consists of. So we have population versus a sample. A sample is representation, small group that represent the population, and the idea here is that in that sense we have a variable which is a character that each individual element of the population or a sample has to have. Example, in the population that the latest popularity to the next president, they are asking that if the person has the right to vote. This is a characteristic population, or his sex, or his education. This is a variable that we need to take into account. So we have the idea of what it is and what it represents with regard to population. So a population is the age of all the faculty at the college, or a sample is the subset of the population. For example, if we will select 10 faculty members and determine the age, probably there will be between the age of 40 to 50, there will be most likely to be female or male, and probably they have some background in, I don't know, never mind. But this is the idea of a sample and the idea of a variables that represent. So the variable age in each faculty is a key component of the sample. If we will take a sample of all the faculty, age will be a constant variable that we'll be able to measure to see if the age is above 30 or above 40 or above 50 in order for us to determine. So the data would be the age of a specific faculty number. The data would be the set of values. So we have experiment, we have the statistics that goes beyond the analysis of the sample, but we also have type of categories. We have 2 types: categorical, a variable that describes the element of the population, and we have numerical variable, again also qualified. So according to our textbook, and today I'm going to refer to a few textbooks quite often, is that the idea of a variable, the two types of a variable, is that it try to give us a value in the form of how this variable come into play. So the resident hall of each student in statistical class, its attribute. The amount of gasoline pound by the next 10 customers at the local Walmart store, it's numerical. And I will talk about more about that throughout the semester, but I want you to pay attention to it. When we talked about the variable in statistics and we talked about sample and population, we also need to think about with our eyes. So again, back to our textbook, it says says that 7% of our body senses captured by our eyes. And according to Colin Ware in 1992, he said, why should we be interested in visualization? Because the human visual system is the pattern seeker of enormous power as substance. So the idea here is that the visualization is our power. An example, this is bad example, but I want you to show you the idea of a sample. The table versus the visualization show the difference between men and a woman with regard to income. And so, as you can see quite fast, is that men earns more even though they should be earned the same. And the visualization capture that quite fast in compared to go month by month and we lose track of it. So this is the idea of the visual why the visual is so important. So our eyes is what we actually see, the image, the eye see, goes to the brain, and the final product what comes out of it. So our job as visual analytic people is to create the most transparent, the most straightforward visualization, so the final image that our brain see will be the actual image that we can actually produce from the data. The idea of visual perception works on a figure versus background. And so one of the things that we will talk about, or we will see example of it, is figure versus background. One of the most basic issue is that the background matches the figure or the figure matches the background. And we will talk about that throughout the semester and we will see that. But we also see a lot of ambiguous images that comes from the art that a lot of visual analytic people try to bring into to the analysis. Ambiguous is that it's not a very clear sense where is the directions, where is the structure of the image with regard to data, and that can be a problem again if you are aiming to display your image or your visual analysis in a bigger scale. We also need to talk about perspective, or the idea of what goes into our minds, what we see and what we actually see in the pictures. So is the pictures on the left, is she a young woman or old woman? This is something that we need to be concerned in. The art world is part of the expression. In our case, in visual analytics, we need to be aware of it just to make sure that we are not crossing the lines and trying to overdo it. One of the things that is really common in the visualization community is the idea of Gestalt laws. Gestalt is the idea of patterns that we find in the data, but in this case, patterns that we find in the visualization. So the idea here is the law of the Gestalt is the mechanism of the patterns, and the patterns that we come up with how to capture some or parts of the data in visualization. And again, how do we apply that? Proximity is one of the pure example of the Gestalt theory. It is the things that are closer together are perceived to be as group. And the rule is the best way to emphasize the relationship between different types of data is to place them approximately in a display. So example, in this case, there's the left and the right, and as you can see, we are trying to match them together in order for us to portray. The issue of similarity in visualization is very important. Why? In similarity, we are talking in visualization key, we are talking about shape and colors. So we can put them grouped together and combine or with the spread dimension to assist segmentation. So related visual elements should look similar. And again, similar example, what works best? How can we make sure that the viewer see the difference between A and B and what makes more sense with regard to the attributes? There is other issues that the use of connection to show relationship is also part of the terminology of the Gestalt theory. And again, what works best in order for us to do that, and how do we apply that into visualization. Symmetry is also related to visual elements, or how do we display visual analytics, and this is again an issue of what emphasis are we going to put into it, and how do we apply. And again, this is something that we will see throughout the semester, and I want you to just be aware of it and how to apply that. Closure is another issue that we often talk about in text or in movies, and it also applies to visual analytics. And again, there is a closure example, good one and bad ones, and this is part of the examples that we are trying to see. Relative size is also very important, and similar components of the visual tend to perceive as an object, and so we will see how the figure and the background can play around with that and be able to segmentate or to encounter that. And again, the issue of dots to give directions to the people that are not familiar with the visualization also can help. The issue is how do we apply that, how do we see it, and the issue of how transparency do we need to be in order for us to transfer the value of the data that we analyze in order for us to be correspondent to existing analysis. This is something that we will all see again and again. Overlap is something that we will learn about that in Adobe Illustrator, and the idea is that we can do overlap. And overlap can be a good representation or bad representation. Again, how we put it all together to create a narrative or to create a report of the analysis is a key component. Patterns in motion, again, the issue of motion is also important. Is one of the early example in this slide. I said one of the things that about type of visualization is that sometimes we do not have if there is a motion or not, and this is something really important. And so the attribute that make the correlation or the motion in play is a very important aspect of what our job is as visual analytics people. So again, form of encounter in motion are really important. Moving frames is also, we will learn about moving frames and how we apply them and what we do with them later on. Causality is also important, as especially in causality in statistics, that usually is one causes the other. How do we convert it into visualization is part of the idea that we're going to see and going to learn about that. And again, causality, direct causality, delayed causality, no causality is part of our vocabulary that we're going to convert into into visual. Animation is also, as I said, in 3D and 4D. We will try to figure out how to do that. I'll try to show you an example of it and try to create your own 3D figures and see what it is. Repetition is also key components. If we are listening nowadays to politicians, usually they end up the speech to us by repeat what they have said. In visualization, we have this idea of repetition, and it is the idea that we are repeating the same, such as line, shape, or images, or text, in order for us to repeat or emphasize what we are trying to achieve in this visualization. Again, based on our textbook, it talks about good design. A good design needs to have attributes such as lines, size, shape, and blur, and color, and motion, in order for us to understand or to comprehend what we do. We also have pre-attributes, and in this case, pre-attributes is the idea that help us to comprehend the visualization aspect, and he lists us pre-attribute attributes such as length, 3D position, width, size, blur, intensity, in order for us to understand what is good and what is bad, in order for us to again try to communicate our findings. So building blocks of information in visualization is something that we often talk about. We are understanding of the result in order for us to display the result that will be transparent to what we have found in the data and in our analysis. And again, this is part of the aspect of the class. So this was a little bit a theoretical aspect of the class. I'm going to now move into geographic information. And geographic information is the idea that we are searching for data in your map. All of you have a cell phone, and when you are getting lost or do not know the road to your favorite bakery, you use your phone to give you directions. So the geographical map is basically works the same way as we are going to lay out the visualization that we're going to create. So the maps and image has patterns, as we're going to see, the graph tends relationship, and the data and the text might help us to do correlation or sequences to synchronize and to give us more directions towards. One of the Google attributes to the entire field is the idea of a search engine. But Google also helped a lot with regard to geographical data. And one of the things that they did quite well is provide us the ability to search for tables that already exist with regard to data. So those tables can be kept in Google Drive, and they are already embedded all the data that we need to search for. So this idea of Google table is the idea of how do we search for a table in order for us to do that. Today, I'm going to start with Tableau. And Tableau, one of the things that it has is a public Tableau, which is free to use, and we will learn how to use it. It's not my favorite software. It is a secondary software, but I think you will understand how important Tableau is for us to apply and to visualize our data. So, Google search table, here is the result. This is the table that you're going to search. If you're going to, hold on a second. You're going to search, example, I search Tampa or Florida public libraries. And I said by location. And I searched, and the table came up with Florida public libraries. So basically it is a list of all the tables. And the idea here is, one of the things that I really like about Google is you are able to export it to Google Sheet and be able to open it in your Drive, Google Drive, so you do not have to search for that data again. This is a simple example. You can search, for example, I had students search for Starbucks in Florida. So they have all the Starbucks location throughout Florida or Tampa. I had students who search for rivers and animal houses in Florida, and they found things throughout the use of Google Fusion Table. So this is one aspect. Sorry. I'm playing with my other presentation, sorry. And so the Google Drive will give you the ability to apply that or save it. And this is where the Tableau come into play. So let's go back to my PowerPoint presentation. So what do we do with this idea of visualization? So the table of Florida is created. I will share it with you so you will have the ability to look at that. But Tableau is the ability to visualize it. So what happened here is that the Tableau will open up and be able to present it. However, the tricky part is that if you open a new Tableau window, and it will take some time, it will ask to synchronize your data, connect to your data. You will connect to Google. You will connect and be able to do that. And so you can see he will already found it. He was able to apply that. And now the fun begins. Why is the fun begins? Because this is exploration. So in this case, he will capture the data. The issue that we need to address is what is the columns and what is the row when we are trying to address the issue of a map that we want to create. So in this example, okay, it doesn't allow me to do that. I will do the address and the city, and I will try to see if it match, if it match the issue of the visual. So in this case, I want you to play with the address, the city, the library, the phone, to see what match in order for you to generate this map. And you can see the map can be colored and can be the added value to it. Example, the colors. You can change the colors. You can add size. It doesn't change. You can add labels. You can add more details. And this is about the city. So I want you to start playing with the Tableau and see what it is and be able to understand why is it so important. And this is the end result that I came up with Tableau. So I color it in orange, no particular reason, and this is what you do. So how to create a table, we talked about. So search and collect the data, personal, public, or something that of interest. You will use a Tableau table to order to convert your data to a geographic map, and you're going to post your map on your blog and submit the address of the blog by posting it to Canvas. So this is your assignment. I hope you enjoy it. I hope you will learn about the idea of how the data in Tableau works with regard to the address versus the city versus the name, what works best with regard to the map. And until then, I hope you enjoy it. I hope you will come up with interesting findings. Until next time, have fun.